In section 3, we are going to talk about arc length and sector area for circles. So arc length is a distance between two radii along a section of a curve. So that means is you're looking at basically a piece of the circumference of a circle. So for example, if I have my circle and I have my two radii, my arc length is the distance between them, so on the outside of the circle. So there is a formula to calculate arc length, and they use S to denote arc length, and it equals R times theta. So it is a Greek letter, so where R is the radius, and theta is your central angle. Now, theta here, the measurement of your central angle, is specifically in radians. So if you're given the measurement of a central angle in degrees, you first have to convert that central angle from degrees to radians, and then you'll multiply it by your radius. The next thing is area of a sector. So it is a region enclosed by two radii of a circle and the arc that encloses it. So if we want to look in terms of a picture, we have our circle, we have our two radii. The sector area is the area inside of that. And then it is enclosed by the arc that is on the outside of the circle. So it's a piece of the area of a circle. So arc length, piece of the circumference, area of a sector, piece of the area. So for the formula, we abbreviate A sub S because it stands for area of a sector. And you have to do theta over 360 times pi r squared. So the pi r squared comes from the formula for the area of a circle, and then theta over 360 is, well, what part of the circle, so how many of the degrees of the circle do we want to measure? So r is still the radius, and theta is still the central angle. But in this case, the central angle is in degrees. So the different formulas use the central angle in different measurements. So one of them uses the central angle measured in radians. The other one uses it in degrees. So you want to make sure that your central angle is in the correct form before you use either of the formulas. So let's go ahead and look at some examples. So we have a circle that has a radius of 3 and an arc in this circle that has a central angle of 340 degrees. What is the length of the arc? So if I were to draw a picture of this, 340 degrees is almost the entirety of the circle. So if we're thinking of that is a major arc. So this entire angle here measures 340 degrees, and we have a radius of 3. So if I want to find that length, the first thing I need to do is convert my angle theta, which is in 340 degrees, to radians by multiplying by pi over 180. So it becomes 340 pi over 180. And now I just need to simplify the 340 over 180, which is going to become 17 pi over 9. Now, I don't want to write a decimal here for theta. If I'm going to write a decimal for my answer, I want to wait until the very end. That way my answer is as accurate as possible. So now to find my arc length, I take my radius 3 and multiply it by my angle, 17 pi over 9. What I'm going to do is 3 times 17 which gives me 51 pi over 9. And then I have to see if 51 over 9 simplifies. And it does. So it's going to give us an arc length of 17 pi over 9. Sorry, over 3. Which is, once I simplify it, it's about 17.8. So for our next example, we have a circle with a radius of 1 and it has an arc with a 20-degree central angle. What is the length of the arc? So in this time, we have our circle, we have our radius, and our angle is right here in the middle. It's very small, about 20 degrees, so we want to find this distance. So again, I have to first take my angle theta, and I have to take my 20 degrees and multiply by pi over 180, which is going to become 20 pi over 180. And I just need to simplify the 20 over 180, which is going to become pi over 9. So for my arc length, take my radius 1, multiply it by pi over 9, and I'm going to get an arc length of pi over 9, which is about 0.35. So very, very short distance for our arc length. All right. So let's go ahead and deal with some examples where our central angle is already in radians. So we have a circle with a radius of 8 centimeters. It has a central angle that measures 3 radians. What is the length of the arc? I'm not going to draw a picture in this case. So my arc length, I can just take my radius 8, multiply my angle, which is already in radians, so 3. So my arc length is going to be 24 centimeters. Because unlike the previous examples where I didn't have a unit of measurement for my radius, in this one I do. I know my radius is measured in centimeters, so my arc length also needs to be measured in centimeters. Okay, so let's go ahead and solve for a central angle. So we have a circle that has a radius of 4 centimeters and an arc length of 6 centimeters. What is the measure of the central angle? So we'll use our formula, S equals R theta, and we'll plug in the information we know. So the arc length is 6. We don't know the radius, but we know the radius is 4, but we don't know theta. So to solve for theta, we'll just divide by 4. So 6 divided by 4 tells me that theta is 1.5, and then I do need my units here, which are radians. And unless I specifically ask you for the measure of the central angle in degrees, you can leave it in terms of radians. I will specify if I want the measure of the central angle in degrees versus radians. So let's talk about area of a sector. So we have a sector with a central angle of 30 degrees and it has a radius of 12 inches. What is the area of that sector? So for the formula, I'm going to take my theta, which is 30 degrees, over 360 times pi times the radius 12 squared. So 12 squared is 144, which then I'm going to multiply by 30 and then divide by 360. So we're going to get 12 pi and then inches squared for the area of the sector. And if I wanted to write that in terms of a decimal, that is approximately 37.699 inches squared. So we know in our next example that you have a sector that has an area of 49 over 3 pi millimeters squared. with a radius of 7. What is the measure of the central angle in degrees? So very similar to when we were solving for the central angle for an arc length, we'll use our formula. So we know the area, 49 pi over 3, has to equal theta over 360 times pi times the radius 7 squared. So one of the benefits to leaving the area of your sector in terms of pi is that if I need to solve for something, if pi is in my answer, the first step that I'm actually going to do here is to get rid of those pi's because they're going to cancel. Now I'm going to go ahead and square the 7. So we are left with 49 over 3 equals, and then 7 squared is 49. So you end up with 49 theta over 360. Now to solve for theta, we're going to cross multiply. So 49 times 3 is going to be 147 theta equals, and 49 times 360 is 17,640. So then my last step here is going to be to divide both sides by 147. And we're going to get theta equals 120 degrees. The nice thing here with area of the sector, if I want the central angle in degrees, the formula, the angle is in degrees to start with. So I don't have to do anything special if I want to solve for the angle in degrees. I just solve for theta, it's already in degrees. If I had wanted the measurement of the angle in terms of radians, I would have solved for theta just like this, and then my next step would have been to convert it to radians. So for our last example, we have a sector with a central angle of 175 degrees, has a radius of 12 feet. What is the area of the sector? So we're going to use our formula. Area of a sector equals 175 over 360 times pi times the radius 12 squared. So we'll do 12 squared, which is 144, times 175 divided by 360, and we're going to get that the area of our sector is 70 pi feet squared, which if I want to do as a decimal is about 219.91 feet squared. So it is important that you do remember the units if they're given to you, and because this is area, the area is square units. And then for arc length, they're just regular units since it's similar to the circumference, and circumference is just a regular unit as well. So let me know if you have any questions about arc length, area of a sector, and using the formulas.